All right, this is Solving Quadratic Equations by Factoring Part 1. And what I'm going to do is start off by just making sure we're clear on the difference. If you have something like this, f of x equals some sort of a quadratic looking function on the right, this is a function. It's a quadratic function. Now, the reason it's not an equation, let me show you the difference. So this guy is the function. What would be an equation is when you actually have it equal to something. Say it was equal to 0. So we got all the same stuff on the right, but this time it isn't just y equals or f of x equals, it actually equals some kind of a number. And that's the difference. Now it's what we call a quadratic equation. And we're going to learn some techniques how to solve quadratic equations. Today, the technique is one that you've seen before. We're going to use factoring. Now, before we get into actual factoring, I'm going to show you some of the possibilities that can happen when we're trying to solve quadratic equations. There's actually 3 things that can happen. And it's best to view the graph to see what these possibilities might be. The most common that you probably will run into is that you have 2 solutions to your quadratic equation. What this means as far as the graph goes is that if you graph the related function, you would get a graph that does something like this, where you have 2 x-intercepts. Okay, so this would be a graph with 2 solutions. Or maybe the graph opens downward and you have a graph that looks something like this. Okay, so we have 2 x-intercepts, 2 solutions. Now that isn't every situation. Another possibility is that you have only 1 solution. And the graph for some situation like that would be the graph just comes down and touches in one point, goes back up. So we have 1 x-intercept. Okay? Now that can also be the case, so or maybe the graph opens downward, and again, you only have 1 spot where it intersects on the x-axis. Okay? So those are the graphs if you only have 1 solution. Well, there's one more possibility, and that is that you have 0 solutions. So what would that look like on a graph? Well, you might have a situation where the graph simply never touches the x-axis. Okay, so if it doesn't touch the x-axis, that means we have no solutions at all. No x-intercepts, no solutions. So those are kind of the 3 situations that we run into when we're trying to solve. So that takes us now to our first example. Okay, now we don't have the luxury of seeing the graph, but what we are going to do is see if we can solve this thing algebraically with some factoring. So x squared minus x equals 6. I'm going to try and solve this equation. Well, the first really important step is to make sure that you have 0 on one side of the equal sign. So I'm going to move the 6 over, making sure I have 0 on this side here. So this is a must have. Okay, if you're going to solve by factoring, then you have to have 0 on one side of the equal sign. And I always like to move things so that this guy here, the x squared term, stays positive. And that's why I chose to move the 6 over rather than to move the x squared and the negative x to the right side. This keeps the x squared positive. So now what I'm going to do is I'm going to go ahead and factor. So these, of course, in order for the factoring method to work, well, they have to factor. If they don't factor, then there's no way we can solve it using factoring. So we have x minus 3 and x plus 2. Now the beauty is we have 0 over here, so we're going to use something called the 0 property to develop our solutions. Our solutions would be that x could be 3, because if I put a positive 3 in here for x, I'm going to get 3 minus 3, which is 0, and 0 times whatever number I get here will equal 0. So this is one of my solutions. The other solution is to turn x plus 2 into 0, and that would mean x needs to be negative 2. So these are my solutions, and I am done with this example. My next example is a little bit different. What I'm going to do in this example is I'm going to try to create a quadratic equation. So create a quadratic equation and what I'm going to do is I'm going to give you the solutions. Given the solutions are, say, 7 and negative 2. So this time somebody went ahead and they solved it. We know what the solutions are, but can we create the original equation? And what we're going to do is just work backwards. So we figure, hey, 2 solutions, that must mean when this thing was all factored, if you plugged in the 7, you must be able to get a 0. So if I do this, if I put 7 in for x, then this would turn 7 minus 7 into 0. So that looks pretty good. What about this negative 2? Well, what if I went x plus 2? So if I put negative 2 in for the x, then this would be 0. Well, guess what? This looks pretty good. The only thing left to do is to expand out the brackets and make it look like a quadratic equation. So I get x squared, then I get plus 2x, then I get negative 7x, and finally negative 14 equals 0. And I'll put together the middle terms. So here's my actual equation. Somebody went ahead and solved it and told us the solutions, and now we're able to create the equation from which these solutions work. And that is where I am going to stop for today.